Okay, so today what we're going to be talking about is states of matter and phase change notes. So most of you guys should have started your data collection for the ice melt lab. In doing so, what all you're doing is observing, you're recording data, and you guys are going to be analyzing that data. All right. These notes are going to help you analyze that data. What they will also help you do is answer the questions on your lab reflection for the ice melt lab. Okay, so what I want you doing right now is get out a separate sheet of paper, and I want you to go ahead and write out your notes. I'm going to be having you guys submit your notes online, so I know you're taking them, but they will also be something, a valuable tool that will be helping you during these lab reflections. So, moving on. So go ahead and label this states of matter and phase change notes. So when we talk about states of matter, you guys know three of them: solid, liquid, and gas. Okay, so what that means is what a solid is anything like ice or a bar of steel, but we know they have what's called a definite shape and definite volume. Okay, so if I had a bar of steel, it doesn't matter if I heat it up. Okay, it's still going to probably be in the same shape. Okay, if I have ice, okay, it's going to have a specific shape and it's not going to change. When it has a definite volume, it means it's not changing. All right. So if I fill up water and I freeze it to a bowl, it will have a definite volume of the bowl. Okay. It's also going to have a definite shape of the bowl. So definite just means it doesn't change. Indefinite means it changes. And if you need to write that down, I would go ahead and do that. Okay. So a liquid has no definite shape, but it has definite volume. It means if I have 100 milliliters, or let's just say I have 2 cups of water, if I pour it into a bowl, it has no definite shape because it'll fill the shape of the bowl. Well, if I put it in a glass box, it will fill the shape of the box. So the shape of it's going to change. It will fill whatever it goes into. Now, the volume will stay the same. If I put it in the bowl, it's still 2 cups. If I put it in the box, it's still 2 cups. So the volume stays the same because I haven't changed it. The only thing that's going to change it is whatever I pour that liquid into, and it will take the shape of that container. That is why it says no definite shape, okay? Or we call that indefinite shape. Gas has no definite shape and no definite volume. Reason being, well, let's just say I have gas. Let me see if I can find something around me. Let's just say I have gas in my cup. So I have oxygen in here. Okay, it has no definite shape because it's going to take the shape of this cup. It has no definite volume because it's going to spread out to fill up the cup, right? Well, let's say I open up the cup. Well, my gas is not going to stay in this cup. My gas is now filling the shape of my room. It's also taking the volume of the room. It's going to be more spread out, but my gas is going to spread out. That's what it means. So it has no definite shape and no definite volume. So you guys can kind of see with the pictures down here. If you guys are having a hard time understanding definite and indefinite, please ask me in class if I have you, or go ahead and send me an email, and I'd be glad to help you with that. So moving on. So I want you guys to look at this picture and fill in the blank. Okay, so on your sheet, if you want to right now, is you can pause this video, but I've given you the options. So the brick either has an indefinite or definite shape, and it has an indefinite or definite volume. So go ahead and pause and fill these in. Okay, so what you should have said is the brick is solid, so therefore it has a definite shape and it has a definite volume. Okay, because its shape stays the same because it's solid, and its volume is going to stay the same because it's solid. Okay, and if you're unsure where to find that, that's in the back. Okay, so it tells you right up here, solids have a definite shape and definite volume. So the next one, I want you to go ahead. A volcano smoke gas has a blank shape and a blank volume. So go ahead and pause this and write this down, what your answers are. Okay, and because the volcano smoke is a gas, it has an indefinite or no definite shape. and it has an indefinite volume or a no definite volume. It's going to go ahead and fill whatever it's in, okay? Now, looking at the picture, fill in the blank. So milk has a blank what shape and has a blank volume. So go ahead and pause this and go ahead and write these down. Okay, these are going to be examples you guys are going to see over and over and over. So you should have said milk is a liquid that has a indefinite shape because it fills whatever container it's in, but will have a definite volume. So moving on. We have multiple phase changes. These are very familiar. So we have 4 that you guys are familiar with. We have 2 that you're going to be learning today. So melting is anytime a solid goes to a liquid. I would write that down. Okay, and how do we do that? We add heat to a solid. Okay. Freezing is the opposite of melting. It's when a liquid goes to a solid. So we take away heat or we subtract the heat for that to happen. Condensation is when we go from a gas to a liquid. Okay, and that is also we're taking away heat. And when a liquid goes to a gas, it's called boiling or vaporization. Okay, and we have to add heat. So melting and boiling and vaporing are going to be adding heat. Freezing and condensing are you're taking away heat. Okay, so write these down. If you need to pause the video, please do that now. There are 2 phase changes that we have not learned, and these are brand new. Okay, and you're going to see these. Mr. Sasfi is going to show you. I will show you in class sublimation for sure. Okay, so it's when a solid goes to a gas and it skips the liquid phase. So imagine just water. Imagine having ice, okay, and it goes straight to a gas. Okay, well, think about it. If you put it into a pan that's so hot and you stick that ice, imagine it not being a liquid first, and it just went ahead and it vaporized really quick. That is what sublimation is. Okay, so it's a solid going to a gas, skipping the liquid phase. Okay, an example we have here is when dry ice is brought out of a freezer, it turns directly into a gas. Okay, so you can see ice here going into a gas. It's not melting at all. It is sublimating. Deposition is obviously the opposite, is when a gas goes to a solid. So you guys see this usually in the mornings, okay? Most times in the winter is when we have a gas, which is usually vapor or water vapor. And if it freezes very, very cold to a solid, okay? So when you're outside, gas sticks to leaves and turns directly into ice if it's super cold. That is deposition. Okay, so please write these down. Okay, you will be using these. Okay, so phase change. What is a phase change? It is a change of state from solid, liquid, or gas to a different state. So it could be any of the ones that we discussed just previously. Okay, and do you think this is a physical or a chemical change? And I know we've briefly talked about physical or chemical changes. But would you think this is physical or chemical? So go ahead and pause this and tell me what you think it is. Okay, your answer should have been it's a physical change. And the reason being is because if you go ahead and take a liquid water and you freeze it, it's still water. You've just changed its physical property. Okay, you've changed its free flowingness to something that's very solid. Okay, but if I put it in my mouth, it's still water. It's still going to have the same properties as if it was a liquid. Now, you guys are going to be looking at phase change graphs, and you guys have to be able to identify when something is freezing, melting, condensing, vaporizing, if something's a solid, liquid, or a gas. Now, during your lab, you guys actually made a graph, and we're actually going to analyze those graphs. Okay, to see if you guys can point out when something's a solid, liquid, or gas. Okay, now, when we look at this, anytime we see these slopes, we are talking about states of matter. Sorry, we're talking about states of matter. Okay, so down here, it's going to be a solid. In the middle, it's going to be a liquid, and up here is going to be a gas. Now, how you read the graph. The x-axis is going to be the amount of heat added. Okay, and the y-axis is temperature. Okay, so as my temperature increases, the amount of heat added also increases. So the more heat I add to a pan, okay, if you're cooking or anything like that, the temperature is going to go up. So what I want you to do is go ahead and pause this video and draw this exact graph. You are going to use this graph continuously, and it might even be on your test. So if you're listening to me now, please stop the video, draw this exact graph. Okay, you should have unpaused me now. All right. And so what we're going to go ahead and do is if we look, well, solids down at the bottom because the heat added is minimum. Because notice as we go right to left, my heat gets added. So I'm going to have less heat to the left over here. So obviously, the less heat you have, the colder it can be. So solids are going to be first. Well, if I add more heat, a solid going right is going to melt to a liquid. Okay, so as I add more heat, a solid melts to a liquid. Okay, so as I add more heat, my liquid temperature is going to increase until I get to a point where my liquid is too hot. Once it gets too hot, it starts boiling or vaporizing. Okay, and when it starts vaporizing, it's in this kind of phase where it's flat because it's partially liquid and it's partially gas because the liquid has to get hot enough for all of it to become a gas. Once it hits a certain temperature and it's all gas, it starts to increase. Okay. Looking at it the opposite way, if I have a gas, well, if I take away heat or I make something colder, it's going to start what we call condensing. Okay, so we see this outside. Okay, if you guys wake up and there's dew on the grass, it's because the grass got cold or the air got cold, condensed the liquid, and now you see that liquid on the grass. So we've taken away heat, and now it becomes a liquid. If I keep taking heat away, it's going to start freezing. So if I have water and I get it to a certain temperature, it's now going to start freezing and it's going to become ice or a solid. Okay, so this is a graph that you guys are going to have to be able to identify. All right, moving on. So notice on the graph, where are we seeing freezing and melting? Well, remember, freezing and melting are going to be between a solid and a liquid. Okay, so going from a solid to a liquid, we have to add heat, so we're going to be melting. And to go from a liquid to a solid, we're going to be freezing because we're going to be taking heat away. So they're opposites of each other. One's adding heat, which is melting. One is taking heat away, which is freezing. All right. Now, the next one is between a liquid and a gas. Well, one is vaporizing and one is condensing. Well, vaporizing is when I add heat, liquid becomes a gas. And then condensing is when a gas becomes a liquid. Okay. So you have to be able to tell me where something is going to be vaporizing, condensing, freezing, or melting. If I give you a graph that's empty, and tell me if something is going to be a solid, liquid, or a gas. Now, notes. Phase change when the slope is horizontal. Okay, so this is when a phase changes right here. So from B to C, so on this flat line is a phase change. It's going from a solid to a liquid. If we look at a flat line up here, this horizontal line, this is a phase change from a liquid to a gas. Or if we go in the opposite direction, it could be a gas to a liquid. So when temperature is increasing, they're not changing. So as we see this slope, my temperature is increasing because the slope's increasing. It's still solid, but once it starts getting to point B to C right here, it is going to be changing state. So when it's in this slope C, it is purely liquid and it is only liquid. Okay, so in this C slope, there is no phase change. But once I hit D on this flat line, this is when I start getting another phase change. So make a mental note of that. Flat lines are phase changes, slopes are states. So to pay attention to the letters, A is a solid, okay, B is a solid to liquid or liquid to solid. So this is your phase change is B. C is when it's purely liquid. D is a phase change between liquid and gas. And E is it's just purely gas. So what is happening between B and C? So if we're looking at this line B to C, tell me what's happening. if I'm going from B to C, what is happening? So you can go ahead and pause the video. If you have to go back and look at your graph, do it. Okay, so we know letter A is a solid. So from B to C, you should have said it was going ahead and melting. Okay, so if I said what is happening from C to B, you would say it's freezing. But because this question is saying what's happening from B to C, you should say, hey, Mr. Sassy, because it's going from a solid to a start of a liquid, it's going to be melting. Okay, what is the boiling point of the substance? Okay, so where on here would my boiling be? Okay, so when does something start boiling? So go ahead, if you have to, look back at the graphs. Okay, where in this graph is something boiling? Well, you should have said it was in this D area. Well, because vaporizing, so anything going from a solid to a gas is boiling or vaporizing. It's the same meaning. Okay, so right here, this is my boiling point, right? This is when something's boiling. So if I go to the temperature, my boiling point should have been 100 degrees. Okay, and so if I said, hey, what's my melting point? You should have said it's 0 degrees because that is the temperature at which a solid starts melting to a liquid. Okay, and that answers the next question. And these are degrees Celsius. They are not Fahrenheit. We will be using Celsius in this class. It is metrics. So what I want you guys to do next is you're going to go ahead and complete the ice melt lab reflection using your notes and your lab data, okay? They will help you with the lab, okay? So when you guys finish your lab reflection, submit your notes, also submit your lab reflection in Google Classroom. And then what I want you to go ahead and do, I've gone ahead and I've posted the next lab. So cohort B, you're going to start your chemical and physical change lab on Friday. Cohort A, you're going to begin yours on Monday. Okay. So go ahead and move on.